Students, this video will deal with the 2D rotation, that too about the origin. As you all know that origin has coordinates 0, 0, and therefore it makes calculations simpler. Therefore we will start studying the rotation about origin first. Let us assume that you are given a point P having coordinates x and y, and you are asked to rotate this point through theta degree. As you all know that theta uh, positive angle is taken in the anti-clockwise direction. Therefore let us assume that this point after rotation through theta degree reaches at this position. Call this position as P dash, and let us assume that it has coordinates x dash and y dash. So now we know the values of x, y and theta, and we will calculate the values of x dash and y dash. So to start our calculations, we will use trigonometric equations. So for this, you draw perpendiculars from P to M and P dash to M dash. Now we have got two right angle triangles. We will take them up one by one. So the first right angle triangle is this. Here you know P having x and y coordinates, therefore this distance OM is equal to x and PM is equal to y, as these are the x and y coordinates of this point. From this diagram it is obvious. Now we consider the complete triangle. In this triangle, as it is a right angle triangle, so trigonometric ratios are applicable to it. Therefore, let us assume that the horizontal, this POP side makes an angle of alpha degree with horizontal. Later on, alpha is just an intermediate value. Later on, we will eliminate it from our calculations. So now sine alpha is given by uh, vertical altitude divided by hypotenuse. So altitude is equal to y and hypotenuse is OP. Similarly, cos alpha is given by base divided by hypotenuse. Base in this case is x and hypotenuse is equal to y. So now please preserve these values of sine alpha and cos alpha for further use. Now switch on to the second triangle O P dash and M dash. Here it should be P dash. So O P dash M dash. In this triangle, point P has the coordinates x dash and y dash. Therefore O M dash is equal to x dash and P dash M dash is equal to y dash, as given by these equations. Here we have OP as the radius of the rotation. We have rotated this point to this location. Therefore this radius of location is remains constant. Therefore OP can also be written equal to OP dash. So OP dash and OP, we will be using this identity for further use. So now let's focus the triangle OP dash M dash. In this triangle, this is the right angle, and this angle is theta plus alpha. So sine of alpha plus theta is equal to altitude, which is equal to y dash, divided by hypotenuse, which is actually OP dash, but we have seen that OP dash is equal to OP. Therefore we get this equation. Similarly, cos alpha plus theta is also equal to base, which is x dash, divided by hypotenuse OP dash, which can later be written equal to OP. So now if we use trigonometrical identities, this equation can be replaced with this, because we know sine A plus B is equal to, and this is not okay, sine A cos B plus cos A sin B. So using this identity, we have replaced sine alpha plus theta with this sine alpha plus sine alpha cos theta plus cos alpha sin theta. And similarly, cos alpha plus theta becomes equal to cos alpha cos theta minus sin alpha sin theta using this identity. So now in this equation, as we have calculated the values of sin alpha and cos alpha, so after replacing these values in this equation, we get this. If you have some doubt, we have used these identities which we had calculated earlier. Sin alpha was equal to y over op, and cos alpha was equal to x over op. So after this replacement, we get this set of equations. So now you can see in these equations op can be cancelled out. Similarly, from this equation also op can be cancelled out. So simplified version of these equations becomes this: y cos theta plus x sin theta is equal to y dash, and x cos theta minus y sin theta is equal to x dash. And I have rearranged these equations to standard form. X dash is equal to x cos theta minus y sin theta, and y dash is equal to y cos theta plus x sin theta. So these are equations of rotation. Of course, about the origin. So point of rotation in this case is origin having coordinates 0, 0. Now these equations can be used to calculate the new location of point P dash, which are x dash and y dash, as each and everything on the right hand side is known, so this calculation becomes quite easy. So these set of equations can also be represented in matrix form as this. This is the rotation matrix, and rotation matrix has these four elements. It's a 2 by 2 matrix. Uh, if we use matrix form, then rotation can be represented by using this equation, where this is the new point matrix for the new location of the original point. This is the original point, and this is the rotation matrix, and rotation matrix is multiplied with the point matrix to get the new position of the point. This equation, the same equation, can also be written in this form: P dash is equal to x dash y dash, uh, which is the point matrix, and r theta is the rotation matrix, and pxy is the original point matrix. Hope you understand it. That's enough for the day, and in the next video we will discuss the rotation about a given pivot point. Thank you very much.